So guys, now let's go ahead and probably implement the ridge regression model. Again, for ridge, we have to again be dependent on sklearn. So if I go and search for sklearn ridge regression, this is where the sklearn library is basically present. Again, ridge by default, if you remember, what kind of equation we specifically apply. See, alpha multiplied by the absolute value of w, right? W basically means this is basically my slope, right? By this format, it is basically given, okay? This is also called as L2 regularization. And we have seen this particular formula in my theory part, right? All we have to do is that use this algorithm over here. So from sklearn.linear model, we'll try to apply ridge. So if I go over here, so here you can see from sklearn.linear underscore model, we are going to import ridge. And then we are also going to import mean absolute error R2 square. You can also go ahead with mean squared error and all. Then we initialize ridge. Then we do fit transform on X train scaled and Y train. And then we do the prediction on the X test. Finally, we'll be able to get Y pred. And then we calculate the mean absolute error, R2 score, and all these things are there. So if I execute this here also, I'm able to get 98% accuracy with the help of ridge regression model. Now, before I go ahead, already since we know we have learned in the theory part why exactly ridge regression model is basically used, please do let me know. So this is how we can basically do the prediction with the help of ridge regression model. Now coming to the next one is with respect to the cross validation. So ridge also has a cross validation. Again, you have understood the concept of cross validation. We will basically convert our data set into training and validation data set so that we can perform hyperparameter tuning on this ridge CV. We'll get 5 different accuracies. We'll merge all those accuracies. Okay. We'll basically find out the average. So over here from sklearn linear model, again, I'm going to import ridge CV. Then we are going to initialize this with cross validation is equal to 5, whatever cross validation you want to use. If you want to use 10, go ahead and use 10. If you have a bigger data set, you can go ahead and use 10. Then I did ridge CV.fit on X train scaled Y train. And then finally we did predict on X test scaled. I got my prediction data. Then we plotted it. We calculated a mean absolute error and all. And finally, I'll also be able to see. So here also I'm able to get 98% accuracy with respect to the mean absolute error is this much. And this is how the projection looks like. And finally, if you probably go and see what all parameters has got selected. So here you can see alpha per target value is false. Alpha's values that is basically getting selected is this much. CV value is 5. So these are coming from all these things, all these values that has got selected with respect to that particular algorithm. So if I probably go and search for sklearn ridge CV, okay. If you want to know more about it, you can probably see it from this particular library itself. Okay. So here you can see different alpha values is there. Again, initialized. You can understand what exactly this is, right? And you will completely get an idea because I have covered all these things in the theory part itself. Okay. So quickly, let's go and see this with respect to ridge. I've also got this, right? Now, similarly, ElasticNet, it is the combination of both ridge and lasso. So again, from sklearn.linear model, I've imported ElasticNet and just go ahead and see this. Here I'm getting 87%, but it has combined both ridge and lasso based on the equation that we have. So if you want to again go and see this, so just go and search for ElasticNet. Okay, sklearn ElasticNet. And here also I will be using by default some alpha value, L1 value and all. This is the formula with respect to the minimization function. So here I will be having one alpha value, two alpha values. Alpha and lambda are one and the same, okay? Lambda 1, lambda 2 that we have written in the equation. Over here they have given as alpha value, okay? So don't get confused with that because mathematically in most of the research paper it is written in that specific way. So this is what we have done it over here. We have basically computed our error rate and then we have this alpha 1, our L1 ratio, okay? Then L2 ratio with respect to this. So this is the formula for ridge. This is the formula for lasso. Okay. And if you probably see in that way, it is just one and the same thing. Okay. Don't get confused by this mathematical equation. So yes, here it is. And here's again, you can also try with basically ElasticNet CV. Okay. So here you are basically able to get 98%. So in this video, we have basically seen that how to probably calculate the ridge and get the accuracy. And obviously after this, what we do, whichever is giving you the best accuracy, go and convert that into the pickle file and use that specific model for doing the prediction. Okay. So yes, this was it from my side. I hope you are able to understand, guys. I know many people may get confused with respect to reading this documentation. Don't worry about this, because whatever theory part we have covered, right, try to apply with respect to that. See, in ElasticNet, this is the formula. The same formula I've written it. If you probably see my PDF sheet that is given as in the resource, you'll be able to understand. In Lasso CV, in Lasso, you'll all be able to see different equation. And this is how we have basically applied over them. Okay. So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video.